Hello, it's Simon, and I'm going to present for you my Computer Science 101 final project. This time, I made a Python RESTful API. RESTful is a representational state transfer, and API is an application programming interface. And an application programming interface by nature is just some kind of other program that runs that another program can hijack off of to perform computational tasks or get computational information or blah blah blah. And RESTful has to do with the fact that this can be done through HTTP requests, or URLs as they're commonly known. And this is interesting because you can really power a website with this kind of thing. And in this project, you'll see that I power a front-end website with a back-end RESTful API using Python. As a brief overview, the Python backend, it starts by parsing poems. I chose poems as the data, written in Markdown, and it reads the poems into a dynamic array. And the poems have headers on them that I'll go into. I'll talk about those more later. And it routes HTTP requests to endpoints on itself. Endpoints are just an URL. Really, URL positions, like permanent URL links. And depending on the endpoint, it'll do different things and send different data. And the data that it sends, after it takes in this markdown data and holds it into its own record system, it sends the data to a client encoded in JSON. JSON is JavaScript object notation. It's used in web development often. And it also sends error messages to the client accordingly. The front end, written in Elm, it acts as a single-page web application, meaning that it does not require page reload when you load in new HTML, as opposed to a normal web page. And it requests data, in this case poems, and it parses the poems, which will be JSON encoded from the backend, into its own memory. So we got a little symbiotic relationship between the two programs, and they're two completely separate programs, and they stand alone from each other, but they will not run properly without the other one. The front end handles errors gracefully, meaning that when the server says, hey, this thing went wrong, it shows the client, the user connected on the website, it shows them that error. And it's also type safe, so the Elm front end, it's written in a language called Elm. I didn't include that, I don't think. It's type safe, so it doesn't compile, actually. It compiles to JavaScript, but it enforces the types that you choose, so it makes it very easy to debug. The motivation for this project was that my mentor, he has a passion for web development, and especially web application development, and he's done various projects, and he inspired me. I really wanted to try out sending JSON over the wire. I thought it would be interesting to see what sending HTTP requests would be like and creating an API. And I'm going to probably add this to my own website when I'm done. I'll modify it accordingly, but I think this is a good thing to go off of. And I also really wanted to learn Elm. I wanted to figure out a good excuse to learn the front-end language Elm. So for the back end, the first step is the Python application reads and parses Markdown files into a dynamic array, like I said. I created my own dynamic array for this project, similar to what we did in class. I'll call it simple, very simple, but it's also really efficient with memory because it's contiguous items in memory rather than a bunch of allocated things in the heap where they're linked with pointers and stuff. It's all contiguous, and it's quick. It enumerates over it very quickly, and it will send it very quickly. It's very low latency. So upon startup, it gathers all these files and reads them, and the array resizes accordingly. And on startup, it's slow because it's resizing this array, which takes a while. It's like a Python list would be. It keeps resizing itself. And that's the first drawback, but once it starts running, there's really no drawbacks because you have that contiguous static item in memory that never changes. And it's not scalable, sadly, but it demands very little memory. the file system that it reads from, each file is unique because of the nature of a file system. They're all markdown files. So if you had an endpoint with a post name or like a poem name, it would be unique to any other poem name. So you can ensure that all the files that you access are going to be unique. You don't have to worry about one URL leading to multiple different endpoints. It's pretty interesting. Step 2. The Python application sets up listeners on a specified port. In debug mode, I use port 4000 on my local machine. And you see I have 3 endpoints listed. I have post route being an argument that gets piped into the function that processes it, and post landing. So post just hands you all the poems. I call them posts because that's a nice term to use for the object. It hands you all the poems with the body, the title, the subtitle, the date, and it gives you that, everything, each field. It's a lot of data. And post route gives you a specific post instead of it being a list of posts. It's just one specific post. And post landing will return all the posts, but without the body of the post, so it's very small. It's very little data. And that's to be used on a landing page. And it returns errors to the client, so the client knows what's going on. I mentioned that earlier. There's very limited I/O activity happening on the Python backend. This is good for security because I don't have to worry about hackers hijacking any writing functionality. There's no user-determined writing happening. It's all reading from the file system. To prove that the dynamic array truly is superior, I took benchmark tests using a command line tool called Hyperfine. And you see I used the curl command. It's a Linux command line tool. And I use the get method, meaning that it just is asking for data instead of giving data. And I did it on my local machine, localhost port 4000. And the endpoint is post landing. I tested it with that. The dynamic array has the lowest latency. The mean is 6 milliseconds, you can see here. For a Python list, it takes just about 0.4 milliseconds more. So there's not much difference in performance, but you see when I use the dictionary, it's insanely high. Dictionary is out of the question. But there's still, there's a little bit of difference between the dynamic array and the list. But I took over 300 tests per command, so I know for sure that the dynamic array is superior. The front end, I'll zoom over this because this isn't really relevant to the project, but I still thought it would be appropriate to include it, as it's really the only way I can display the data. It requests from post landing on page startup, and this is an HTTP request, and it parses the JSON it received from the backend into type-safe maps, a map being a record with fields on it, similar to a Python dictionary. And when any action happens on the front end, it's turned into a message, and these actions can take the form of errors or successes and have data attached to them. So it's like a pipeline that's continually flowing, and you can change the state of the application with that. Very, very helpful. Again, a digression, but I thought I should include it. Step 2, after receiving all the JSON from the server, it scaffolds it into HTML elements with the various functions that I have set up on the front end. And then it displays this without the page reloading, so the user just loads the page, and it happens within a few milliseconds. Honestly, it's very quick. And when you click on one of the poems that is generated, it'll take you to that poem specifically. So it's like a true application. When you're on it, you feel like you're actually in an application. I'll give you a demo soon. As a reflection of this project, I faced a few challenges. It was really hard to determine if the dynamic array was worth creating and implementing. It ended up being a good option because it proved to be supreme. But it was still a matter of thinking it over and wondering if the amount of data that I had was appropriate for this situation. And I was wondering if it was even appropriate to cache the poems in the first place into the onboard memory, or if I just should read them as, lazily load them and read them as I went along. And I overcame these two challenges. Well, the first one I said I overcame just by logically thinking through it. And the second one, I decided that for the small scale of this project, it was probably wiser just to cache everything in memory. Another challenge was the markdown parsing algorithm. That took a lot of use of regular expressions, which is not something I wouldn't call myself very good at. But the markdown has headers using hashtags, and the first hashtag is the title, and the second is the subtitle, and so on. It's very intuitive, but it took me a while to figure out how to use character escape sequences and things like that. I did learn a lot, though, I will say that. The successes in this project would be the speed of the application. Honestly, I would consider it pretty fast. The markdown parsing algorithm was a major accomplishment. I felt pretty good about that. And learning Elm was a really big accomplishment as well, because I hadn't ever touched the language until 2 weeks ago, and I made a web app in it, which is impressive for me because I feel like I'm a slow learner. So that is all that I have as far as the technical review of this project. I will now give you a demo. So here is the website on my local host machine, and the website title is Poetry, and this is kind of fun. You can change the colors. But you see that when I load the page, it immediately shows these titles, and they're all in these boxes. And when I make the request, if you look on the left side of the screen, the backend which is right up here, is showing that it's getting a 200 request, and it says post landing, which is the endpoint that I said I was setting up. It's actually sending a request to HTTP localhost 4000 post landing, and it's returning a success. So every time I refresh it, it's making that request. And if I click on one of the poems, it says, I made this request, post, 'twas warm at first like us. And it gave a success back, and you see here that I have the poem. It worked. This is kind of fun to see on first try. It was impressive once I got it working. And you can go back in history, and the page does not reload. You can click on all the poems, and it's very fast, and there's not any loading time. It's pretty fun to click around to mess with the CSS and stuff. And what you see down here is just a Python simple HTTP server serving the file, the main HTML file. And that main HTML file holds a script for the compiled Elm source, which compiles the JavaScript. So, yes. So I appreciate your time, and thank you for watching. Have a good rest of your day.